Hello, Legacy Savers, Marsh here. So today we're going to talk about solving log equations. What you're going to want to have on you is your foldable. You're also going to want your perfect Rutsch chart. You're going to want to find that. And then also I would grab out a calculator today because you're definitely going to need that as well. Our essential question today, how do I solve an equation that contains a logarithm in it? So we're starting with a log, unlike the last couple of days where we started with an exponential. So first thing, kind of a reason for why do we need to talk about equations with logs in it. The equation to figure out the speed of wind inside of a tornado near the center of the tornado is given by the distance the tornado traveled in D in miles by the model. S equals 93 log 10 D plus 65. Now, why would you need this? The main reason why we would need this is then we could decide what kind of speed or what kind of level of tornado was it. Sometimes you'll hear that it was an F5 tornado or an F1. This allows you to determine how much damage and then also how much speed that tornado had in our information. So, real situation that we have here, there was a tornado that struck Moore, Oklahoma in the May of 2013, traveling a distance of approximately 17 miles. The estimated wind speed. So what we could do is we could plug 17. Here, hold on, let me get myself a pen. 17 in for my distance. So I could do this. Log base 10 of 17 plus 65. And using my calculator here, I'm going to do my quick math here. 93 times log. And since that's a common log, I can just use my log button on my calculator, right? So my wind speed at the center of the tornado was 179.43 miles per hour. Super fast, and I believe this was an I think it was an F4 or F5 tornado that they decided it was. But this also could allow you to determine if you knew the estimated wind speed, we could also go backwards and we could find the distance it traveled. That would be another thing that we could be able to determine using what we're going to be talking about today. But first, let's talk a little bit about refresh information. So recently we talked about, well, how does one solve an equation that is an exponential? And what we did is we did two different ways. We said, well, you could get to be the same base. We could say, well, you know what? I know 8 is just 2 cubed, right? So then we could set the two exponents equal to one another, and then we would solve. In this case, we'd get x equals 3. Or the other way we said is we could change it to a log on both sides, right? So change it so that it's a log. So remember, it went from base to answer equals exponent because log is the way to get to the exponent. So what we could do is go log with a base of 2 of 8 equals 2x minus 3. And then we would have to check, what is log base 2 of 8? Well, using our fancy-dancy calculators or using the change of base formula, depending on how you need to do your job on your calculator, I know I have the ability to do log with a certain base on my calculator. If you need to use the change of base formula, you would have to go log of 8 divided by log of 2. I would get an answer of 3. However I do that, 2x minus 3. And then, again, we would solve x equals 3. Ta-da. Okay? So, ultimately, what we're doing is going backwards today. So, we need to solve, just as we didn't need to get our common base, we just don't need our common log. In this case, I don't have to really worry about it. Right? I don't have to worry about the logs because they're the same. So this is the same log on both sides. I really don't care about it anymore. All I care about is 4x minus 7 equals x plus 5, right? I don't need to worry about those logs anymore because They're the same. So if I solve this, I'll get 3x equals 12, right? Subtracting the x, adding the 7. We would get x equals 4. Now here is the if problem with a logarithm. So using your calculator, just the common log, so just base of 10, can you type log of -1 in the calculator for me? You should get unreal answer, right? Does not exist. An error of some kind. What about log of 0? Another error, right? Something that does not work, does not exist. Logs are not allowed to have from an answer that is 0 or below. So one would say the domain, the x values allowed in a logarithmic function, is from parenthesis 0 to infinity. Okay, so I'm allowed 0.1. I'm allowed all numbers above 0. I'm just not allowed a 0 and the negative numbers. So when you are solving a logarithmic equation, there is the possibility of an extraneous solution. So we do need to take that number, the 4, and plug it in to make sure we don't get negatives or a 0 inside the log. So plugging in my 4 here, I'll get 4 times 4, 16, minus 7, that's 9, right? Not a negative, not 0. 4 plus 5 is 9. Notice I get log base 5 of 9 on both sides. Checks out. No extraneous solution here. And actually, works. So how do you solve an equation then that has only a log in it, not logs on both sides? In this case, just like when we had an exponential and we couldn't make the same base on both sides, what we can now do is convert to exponential. So when we had exponentials, we had to convert to log form. If we are in logs, we have to convert to exponential form. So in our case, we're going to go backwards. It's a good thing we practiced that a bunch of times, right? So we're going to go base to the power equals the inside, right? So 2 to the 6th equals x. And 2 to the 6th, we know, using Mr. Calculator or your perfect world chart, x is 64. And again, plugging in that 64, we do not have a 0, nor do we have a negative. So 64 would be a good answer. Let's try it again. So again, log base 5 of x equals 3. I cannot convert, or I can't just go on my own log on both sides. So I'm going to have to convert. So I'm going to stay with the base of the log. 5 to the 3rd equals x. So I'm going to go 5 to the 3rd equals x. And I know 5 to the 3rd is 125 based on my perfect first chart, right? 125, plugging it in for the x, not 0, not negative. And you could use using your calculator, log base 5 of 125 is in fact 3. So you could check your work. So I'm going to put a little checkbox. Let's try it again. So again, can't convert this, right? It's just going to stay log. So x to the 5th equals 32. And on this one, you technically, notice this is not an exponential anymore. Technically, this is a polynomial to solve. So you would have to take the 5th root on both sides. I know, strange, right? So we would actually get the 5th root of 32, which is 2. Just like that, on the logs, base of log, you cannot have 0 and you can't have negatives, but you can have any other base of a log. You just can't have zeros and negatives. So 2 is in fact all right. Okay, a little bit harder now, right? So now notice we have a bunch of stuff inside the log. Not much different. We're still going to convert to exponential first. We're just going to have to do a little bit of solving when we're done. So we're going to start at 2 to the 3rd equals x minus 3, or x minus 4, excuse me. Just like that. 2 to the 3rd, we know that's 8. So adding 4, I'm going to get 12 equals x. And I'm going to plug it back in. 12 minus 4, that is 8. And that is not 0, nor is it negative. So we're all good there. Ooh, a natural log. Dun, dun, dun. So now we're going to have to get an e in there. But here's the thing. Do you see how we have 7 plus over here? We need to simplify this. We need to get this so it doesn't look scary. We need the log to be alone. So I'm going to first subtract 7 on both sides. Okay. So I'm going to get ln of x equals negative 3. Now, on this ln, remember ln has just a base of an e right here. So that is the base of every natural log. So I'm going to go e to the negative 3. It's going to give me my x. And using my calculator, e to the negative 3 is, after 4 decimal places, 0.0498, roughly. That is not negative. It is not 0. So I got my answer right there. Little bit more. Again, notice here, we're not alone. That natural log, that log, before you start solving and converting to exponential form, you have to be having it alone. So we got to first divide by 3. So I'll get ln of 3x squared equals 1 over 3, 1/3. Okay, now, again, I'm going to put my little base on ln, put the e there. ln is alone, so now I can convert. So I'll get e to the 1/3 equals 3x squared. I'm going to get e to the 1/3 on my calculator. E to the 1/3, I'm going to round it to about 4 decimal places, so 3956 equals 3x squared. And you know what? Since I have that number on my calculator, I'm just going to use that number, just pushing divide by 3. So I'm going to push division by 3 so that I just keep running with it. I'm just going to keep writing 4 decimal places, though. So 4652 equals x squared. And then I'm going to square root both sides, right? So I'm going to do the square root of my number. And I'm getting 0.6821 for my x. And you know what? I took square root, so I actually get a plus or a minus. 2 answers possible here, people. So if I have 0.6821, notice if I square that, I'm going to get some number. Times 3 is still a positive number, right? Negative, still going to square it. Going to turn positive, times 3, still a number. So both of those answers do in fact work. Now keep in mind, if you took the square root of 0.4652, maybe you're following along with me, you still should have gotten something close to my numbers. That's why I always take about 4 decimal places, because you're pretty much guaranteeing accuracy. And you want to be as accurate as possible. If you only take 2 decimal places throughout the entire problem, you probably will find by the end you will not have an accurate answer compared to me. Ooh, another log on both sides. Well, that's good, right? Easy problem. Log on both sides, both the same base. So then I just get to drop the logs and get some answers going, right? So I got 2x equals -6. So x equals -3. Now you're probably going, oh, Marsh, is this the time? Is it? Is this when we get a number that doesn't work inside the log? I don't know. Let's go see. So if I plug -3 in, 7 times -3 is -21 plus 3, negative. This one has no solution because you cannot have a negative number inside the log, right? You're going to get log base 3 of -18. And if you do that in your calculator, if you type in anything that has a negative inside the log, you're going to get a known real solution. You're going to get an error. So we cannot, there is no solution to this problem. I know that sounds weird, right? But no solution. All right. Oof. Big here. Before, there's some stuff multiplied in here. I'm going to multiply those together. So I'm going to do a quick FOIL gig up in there. So I'm going to get x squared minus 7x plus 12. Just to clean it up, parentheses first, right? Log base 3 of x minus 3. Now I have the same log on both sides. I can just worry about the insides. Like that. I now need to move everybody to the same side. So I'll get x squared minus 8x plus 15. Oh, a factoring problem. Oh, should have known. So x and x. Things that make 15. 3 and 5. And both negative. That'll give me a negative 8. So I'll get two answers, right? X equals 3, X equals 5. Now, before we keep going, we better check to make sure there's no negatives if I plug those in. And you know what? I'm noticing it right here. 3 minus 3 will give me a 0. Not a good answer, right? Can't have of 0 inside of a log. Now, 5, we'll get a 2 here, and then I could plug it in here, but that I'm more likely to mess up with the multiplication. I just foiled, so I'm just going to plug it into here. 25 minus 35 is negative 10, plus 12 is 2. So that one looks like it is, in fact, okay to have an answer of 5. And, almost last problem. Let's convert. Lost my pen. Let's convert. So I get 2 to the 5th equals 5x plus 7. 2 to the 5th is 32. 32 minus 7. Marsh doesn't know what that is off the top of her head here. That is 25. So x equals 5. Again, plug it in. Definitely a positive number. All good. No problems there for our answer. And for our final problem of the video. So again, log is alone. Convert here. 3 cubed equals x squared minus 6x. 3 cubed I know is 27. And I'm also going to move it to the other side. Double work here. Oh, another factoring problem. Oh, you spoil me. So I'm going to go x and an x, 9 and a 3 to make 27, I think. I need a negative 6, though. So negative 9, positive 3. So x equals 9 and x equals negative 3. Now I'm going to check them both, right? So if I plug 9 in, I'll get 81 minus 54. Definitely an okay number, right? Negative 3, that would be a 9 plus 18. Ooh, that is not a negative. I know, almost thought so, right? But that one also works. So we have two different answers for this problem. So don't assume just because your x is a negative, don't assume that that's an extraneous solution. Be careful. Plug it in. Check it. Is it 0 or negative? Then you can't have that inside your log. And with that, that is the end of this video. I hope you enjoyed working with log equations, and I hope we get to keep practicing them together. Until then, I'll see you later, Sabers.